On August 3rd, 1914, the major powers launched the war nobody wanted. It was to be the most devastating of all time.
The story of the Haber-Bosch process is a dark, brilliant, and deeply complicated tale.
He explored the possibility of manufacturing ammonia directly from nitrogen and hydrogen.
It is often called the most important invention of the 20th century, or in human civilization and our ability to feed billions. It is a story of how two German chemists found a way to catch the air to feed billions of people, while simultaneously creating the weapons that killed millions.
In the first month, the great armies clashed in a series of murderous battles, finally ending in a stalemate stretching from Switzerland to
In the late
North Sea.
1800s, life across much of the world still looked very similar. Most people lived close to where they were born, traveled little, and grew their own food. Agriculture was almost entirely constrained by what nature could provide. At the time, the world simply did not have enough nitrogen to produce food that it needed. Natural and biological sources were limited. Not enough from manure, not enough from plant material, not even enough to produce the feed needed to sustain the animals farmers depended on for traction. There was simply not enough. Not enough to feed rapidly growing populations, definitely not as millions of people were leaving rural areas and moving into expanding cities. And getting a sufficient nitrogen source would be the greatest challenge for the 20th century. There were attempts to fill the gap. Europe imported enormous quantities of bird droppings or guano, but these deposits were thinning and being depleted. Nitrates were mined from Chile, but that came with geopolitical risks and limited reserves. Scientists even experimented with using electricity to fix atmospheric nitrogen, but the process was enormously energy intensive and could not be produced economically to produce fertilizer on a massive scale that modern agriculture would eventually require. The problem was becoming increasingly clear. The world needed a way to manufacture nitrogen at industrial scale.
But it was clear that Chile's limited deposits would soon be exhausted and that a shortage of nitrogen fertilizer would have disastrous consequences. At the turn of the century, with the world population increasing at a tremendous rate, it was obvious that food would soon be in short supply.
Look around you. Everywhere you see life, you see nitrogen. It is a building block of amino acids, proteins, plants, animals. From the garden outside your house, to your own body, to your pets. Look at any plant, and nitrogen is there. And look up. More than 3/4 of the air around you is nitrogen. It is literally everywhere. So how could the world possibly run short of nitrogen? The problem was that most of the nitrogen was essentially locked away in the atmosphere. Atmospheric nitrogen cannot simply be absorbed by plants. To become useful in agriculture, it has to be converted into forms plants can actually take up, such as ammonium and nitrate. Farmers could get some of this usable nitrogen from organic sources, crop residues, animal manure, and green manures. But there was a problem. There simply wasn't enough. In the old days, crop yields were incredibly low by modern standards. A wheat harvest of around 500 kilograms per hectare would have not been unusual. And remember, a hectare is roughly the size of 2 football fields. If that farmer left the crop residue on the field and recycled them back into the soil, only a small amount of nitrogen would actually be returned, roughly 2 kilograms of nitrogen per hectare, nowhere near enough to replace what the crop had removed. Farmers could improve the situation by rotating crops with legumes such as beans. Leguminous plants have a remarkable relationship with bacteria that fix nitrogen. Then there was another thing. There was manure. Animal waste could provide considerably more nitrogen than crop residues. But even manure had its limitations. Its nitrogen content varied. Much of the nitrogen could be lost, and the animals themselves depended on feed that ultimately came from the same limited agricultural system. So the nitrogen gap was closing, but only slightly. And this is where we need to kill a popular romantic idea about agriculture. There is a tendency to imagine the past as some agricultural golden age where our ancestors produced abundant food with almost no environmental impact. No. Farming in the past was brutal, uncertain, and remarkably unproductive. When people imagine a farmer growing maize 400 years ago, they imagine and picture something resembling the long fat ears of maize we throw into the braai today. That is not what they would have harvested. They would have harvested something much smaller. Yes, selective breeding dramatically improved what crops were capable of producing. But genetics can only take you so far. You still have to supply the nutrients required to realize that genetic potential. And that is why, alongside improving crops through breeding and selection, farmers and scientists had another problem to solve. Where were they going to get enough nitrogen? During the 19th century, several technologies and practices were developed to increase the supply of fixed nitrogen. One of them, recovering ammonia as a byproduct of coal coking, eventually produced relatively significant quantities. But none of these approaches solved the fundamental problem. They were useful additions, but they were not a reliable long-term solution to supplying agriculture with the enormous quantities of fixed nitrogen it would eventually require. And then came another source, a source with a rather unusual history.